Hello everybody, this is Svan, your colleague from Kingston University. Once again, with another tutorial. Today we're going to talk about the solving and post-processing in the finite elements analysis using the Siemens NX. And so we already done the meshing, we already make ourselves familiar with the user interface of finite elements analysis, parts of the Siemens and finite elements modeling. So now we are ready to actually solve it and study the results as well. Today we're going to talk about the simulation environment. I'm going to talk about the post-processing navigator, how we'd be able to create the graphs, the viewports, also how we'd be able to animate the results and create the reports at the end. The simulation environment, so we already seen how we'd be able to make a new part files, but this one is a simulation which I'm gonna show it to you, and also we will discuss about how we can define the simulation, what's the difference between those, and also the different types of the simulations, the solution monitor. So I'm gonna just show all of them in one example because it would be easier to understand it, and also the simulation navigator, which we're gonna talk about it. Then we go with the post-processing. So let's see how we can do those. I'm gonna open one file that we've used before. So great, so this is the file that we've practiced before, but it's just a file, doesn't matter what it is. So if you see, actually it's a .prt, so it's the part file. What we need to do, we want to study in the finite elements modeling and finite elements simulation. So as I mentioned earlier, there are different ways of doing that. One of the ways, we go to the file, when we start the new pre and post processing, or I can go to the application. So we are in home, application, we are into the modeling, we go to the pre-post, and you see that actually you have the new film and simulation here, which I need to click. New finite elements modeling and simulation, because every simulation file needs the finite elements modeling as well. So it's a finite elements modeling file, simulation file that is going to create it for me automatically. In here, I need to choose what body I want to import. So if in case you use the split bodies, which means that you have two parts, so I would be able to choose select and only choose the part that I'm going to import, or all visible. So whatever, I have just one body, even if I choose select, it would be one body that I'm importing, doesn't matter. Geometry options, so if in case you have just the arcs or lines you want to import, we use these, but here because it's a 3D part, I'm going to import everything, so I don't use that. Solver, NX by default use the NX Nastran. It's one of the best ones, which is really good, but these are the different solvers that as well is available, which we would be able to use. For instance, we have the ANSYS, we can use it. We can use the fluid and thermal one if you want to study, for instance, the thermal analysis, or LS-Liner, which is good for car crashes. But NX Nastran is the one we're going to use, and most of the time it's really powerful solver to use. And also it's a structural analysis, so if in case you have a thermal or different kind of analysis, you will use those. It's a structure. Also do the solid option, there is no need for do that because it's not a 2D solid, so we'll just click OK. And the solution part will appear. In the solution part, you would be able to rename your solution or name it and change the names. Again, you will be able to change the solver names once again, and change the type of the analysis or even the solution subtype. So for instance, here is a linear static. So it's a linear study we're going to do. If in case we're going to do another kind of a study for instance, the linear background, we'll be able to change it here and define it here. So everything's fine. I will click OK. So this is one way of coming to the finite elements modeling and simulations. The another way which I can do that, I can actually make the only simulation. If in case you have the finite elements modeling file, you just need to create the new simulation. What you need to do, you go to new. So by default, you're in model. You'll move to the simulation, finite elements modeling file, or simulation. I just want to, for instance, create the simulation. And if I click OK, it would ask me, what file do you want me to import for you? For instance, I will choose this one. I can also open the another file that I want to import. I'll click OK. Like before, it will show it to me. Solution, I can change it. So whatever we are doing in this simulation, you see that actually that was the simulation I created. That's a previous simulation that I've created with different methods. So you will see them in here. If in case you're happy with that and you want to close it down, you just right click to it and click close, and it will close. Okay, so let me change my window and go to the power simulation we're working with. Okay, so in here, this is the finite elements modeling level, mesh level, simulation level. And you see actually once I click on those, the menu bar would change as well. Okay, so now what you need to do, we just need to mesh it first before actually we start the simulation. So I'm into the mesh level, so I double click to make sure I'm the mesh level, and you see that actually it has the mesh sign next to it. And I'm gonna mesh it. So basically, because I have a 3D model, so I'm gonna use a 3D mesh. I can use the 3D tetrahedral or swab mesh. This one's a simple geometry. I go with the 3D tetrahedral. I need to choose the body, which I'm gonna apply the mesh to it. I can change the type of it, so I'm gonna go with a set C tetra with a 10 nodes. Element size, let me put 30 for instance. It's too much, it will show me error. I'm gonna show it to you. And if I click OK, it would ask me, are you sure that you wanted to continue with that? And if I skip it, you'll see that actually I've created the element size of this 30 millimeter. And also in here, you see that actually my mesh is created. If I click on plus, it's the solid group. We put it as the mesh collector solid and 3D mesh. And I have 240 elements, which is really low. I need to increase it. So if I want to change it, I will double click on that and will decrease the size to 5 millimeter. So I'm happy with the 50% surface increase in internal meshing. I've already discussed about this before. So this is if in case you want to have a local mesh increase in the internal parts or even the curvatures, you will use those. And I will click OK. So you see now actually my element count has been increased to 4,723, and I have a good amount of elements over there. So I've done that. I need to apply the material to it as well. So I can go there, edit. You see that actually. So what I need to do, 3, 2, 1, go. So what I need to do now, I need to define the material, because I want to give the solver the material. Without the material, it doesn't know the characteristics of the part you have. So I need to define the material. So what I do, I'll go to the mesh collector level, which is this one, solid. I'll right click, go to edit. Now you see that actually I have a solid property. Next to it is the edit option. And I can change the material in here. So let's change it to the steel, for instance. And we click OK, it's isotropic. We click OK. Okay. So I already have the material, I've done the mesh. Now I need to put the loads and forces. I will go to the simulation level. What I need to do, I need to put the constraint and put the load. So for any software you're using, doesn't matter what software is that, once you want to do the finite elements modeling, you always have these steps. You have the pre-processing, solution, and post-processing. In the pre-processing, you need to define the geometry. This is the first step we've done. We import the part, material properties, we define the materials. And now I need to put the load and a condition with that. Also, we discretize the model as well. So we've done the meshing for it based on the structure we have. Now we need to add the assumption to it, whether based on the study we're going to have. So we need to tell the solver what kind of a study we're going to do it. So we've already done that. In the solution we define it, but we just need to apply the solution to it. And also put the forces and the post-processing, which will be the last stage. Once we get the result, we analyze those results. So these are the stages we are following. So let me go back to the model. So I've done the mesh. As you can see in here, I need to add the constraint to it. But I'm gonna fix it. So here I'm gonna use, so these are the different kind of, constraint I will be able to add, which you need to familiar yourself based on the different needs, different techniques you're gonna use. We have 3 upcoming tutorials that we are using different kind of these constraint type to be able to find out when we are using it actually. So let me use the fixed constraint for here because I'm gonna fix every single elements of one area of the part that I have. So what I'm gonna do, I'm gonna click here. So it fix every single node's elements of that hole that I have over there. If I click OK, you see it actually is fix it for me and show it to me because every single element has been fixed. And I'm gonna insert the force in there. So I'll go to the load again, the different kind of forces based on different kind of study you want to have, different forces applied to your part. I'm gonna use a normal force, which is applying to the again every single elements of that hole over there. I'm gonna put 2000 newtons for instance. I need to define the directions. So I'm gonna choose z-axis and reverse it because I won't have the negative z. I'll see it actually fixtures and also the forces that I inserted to the part. Great. So I'm ready to go. I just need to solve the model. So if I want to solve it, because I already have the solution I actually created earlier, just click on solve. And this is the solve option, so I can solve it if I have the input file as well. So here just a normal solve, I will click on that. And now the NX Nastran use the full train is the code behind that goes through the simulations and the coding behind it, so I can see what's going on with model. If in case I have an error, it would be appear there. So it is the information about what's going on with that. Once I finish it, I can close this one down. And you see it here, actually it's the analysis job monitor. So it show me whether the job is completed or it still is progress, so make sure it's completed. What is completed, I can close it down with cancel. And you see the result is appeared here with a sign next to it. If I click on plus, you see that actually it's a structure, that's the study I've done, and it's colorful. So once it's colored, then actually you have the successful result. If not, you don't have a result, there is an issue. You need to come back and see those errors that actually what was error. So if I double click on it, so I go to the post-process navigator. We've been into the simulation navigator, and now we move to the post-processing navigator. So these are the different kind of results we get from the model. So this is what these slides talking about, the post-processing navigator, the way we will be able to get the plots out of it, how we can make the graphs, which I want to talk about it, and creating the viewport as well, and how we'll be able to animate the results and get the report at the end. Good. So the result, so it comes by default these sort of things. So I can see the displacements, for instance, in X direction. I just need to double click on that. Displacement in Y, displacement in Z, or magnitude of all of those. You see, actually, I have a displacement for the 1.63 millimeter over there. Then we go to the stress, so can have the stress elemental, so a stress on every single element, or and an average between the nodes and elements, so it's more accurate. So I can see it in the XX, YY for instance, or if you go to the one misses, which is the one that actually we use a lot. So basically it's the main representation of the stress analysis you have there. So you see the minimum is at 0.29 megapascal, but is a maximum, which is here, the 534.10 megapascal. And that's the first, and that's the stress that I have over there. So if I want to change here, this one is a smooth. So if I go to the quick edit, I can change it to the banded, so it would be more. I can find out the exact area that the levels of stress has been changed in here. Even I can make it as a line, so I can see them as a what exact line that actually is the difference between the stress, for instance, in here, or even displacement over there. Even I can put them as a cube, so you will be able to see the elements that actually they're changing based on the stress applied in here. So I go with the smooth. So this is the one that actually use a lot. Even if I want to find the exact stress in here, with again is a displacement, so you just need to activate it. You go to identify results in here, and I can just choose the node. For instance, there would just give me 472.235 megapascal over there, so you give me the values over there. If I go, for instance, to the displacement, I can do the same thing. I identify the result. I'm gonna go with the highest one, and to see how much displacement I have, and it just show it to me 1.63442. Also, I can search it based on the node ID as well. So even node ID, I just type the node number that I have from there. I also can get the graph out of it as well. So let me create a graph, for instance, in here. With the graph, I just need to choose nodes as well. So you will see I can either type the node IDs in here if I know them, or I can choose the, for instance, 2 points from the model. Let me see, there, and I need to choose the viewpoint there. You see it actually, that's the difference of the displacement between these two nodes, 8492 and 493. Also, what you can do, let me go back to the stress and do that for the stress as well. So you just go there. Let me choose the difference between this one and that one. I need to choose the viewpoint. This is the viewpoint. I see it actually, that's the difference there. Another thing I wanted to mention is actually the viewpoint. So here is a single viewpoint, so we just see one, but I can change it in here. So for example, I can put them two side by side, so it would be easier for me to compare the results. Let me see that, for instance, I want to have the displacement in one side, which is this one, and you see that actually I have the plots in there. Again, one misses, I'll right click to it, I'll click plot. Now I'll ask me to choose a different viewpoint. I'm gonna choose here. So I have the two different viewpoints. This one is showing the displacement. This one is showing me the stress, for instance. So you see it actually, this is how I would be able to choose that. If you want to do me, I do it again for you. So that's a single view. I can change it with a different. Let's make it a triangle this time. So in here, let me go, and because that's my default one, I'm gonna have the displacement on the top, and let's say the stress elemental nodal one misses in the middle. So what I do, I click once, right click, plot. I want to ask me what viewpoint I want to import it. I will just click on there, how you would be able to see it there. And on the third one, what I'm gonna do, let me put the reaction force, for instance, magnitude, plot this one as a reaction force that I've put in. Let me go back to the single view once again. What I'm gonna do, let's say I'm gonna have the stress, but I want to animate it to see how the actually stress works. So in here there's an animation area. If I go to animate, I will be able to change the frame delay. For instance, let's go with the 200. You see, this is how I would be able to animate the model. If I decrease it, it will become faster. So let me decrease this one to just 100. You see, it actually become faster. And if I increase it, it will make it slower. So make it 500. Stop it. And you see now it's slower than before. Click OK. So from now on, if you change the setting, you can just control it in here. So I can play it and pause it as well. Let's see the displacement, for instance. I go there, we'll play these displacements that I have there. So basically we've done those, we've done the animation as well. So what we need to do, we need to create the report. So once we finish everything and we are ready to publish the report, what we would be able to do, if I go to the home, next to the solution, you see there is an option here called create report. And if I click on create report, I need to choose a template in here, but in this case I think because I don't have Java on my machine, it will show an error. But anyway, we'll click OK, and it should do it for you. And I have an issue with the Java, I need to install it on the machine. So in your case that will be fine. So once you're doing that, you will get the reports, and the reports would appear in here. Let me open one model for you with the report so it would be easier for you to see that. Let me open this one, for instance. This is one of the tutorials. We're going to do it together after this part of the lecture. Great. So once you create the report, you will be able to go to the simulation navigator, and you see a report there. So it actually, this is how the report is created. And if I want to check the report, if I go to my saved file, you see that is a simulation report I created. If I click on that, it will show it to me that what was the material, for instance, if I used, the density of it, the yield point of it, what kind of a study that I had, how much forces, for instance, I put, the pressure, whatever. So in here, in this case, was the pressure, and that was the value of the pressure that has been imported, the minimum, maximum, all of those graphs that actually are created as well with the graphs. So this is how we would be able to just get the report out of the NX without just picture screen every single thing. Okay, so that was it for now, and we're gonna continue with the two tutorials, 2 or 3. Let me see how many tutorials that. Two tutorials after this lecture. Thank you. Okay, so let's practice what we learned so far with this tutorial. This is one of the models that actually we created the mid-surface out of it to the previous tutorials. So if you remember, we had this part that we created this mid-surface out of it. So let's study this one, and what I need to do, I need to create a new simulation. So you see, finite elements modeling and simulation file is going to create. I'm going to import everything. Geometry option, I don't change it because I'm going to import everything, and these are surfaces. I'm going to use the NX Nastran solver. It's a structural analysis as well. I will click OK. So what you see here, I can rename my solution. Also, again, I would be able to change the solver, the analysis type, for instance, or even change the solid options. I'm happy with everything, so we'll click just OK. Great. So what you will be able to see here, this is the model level. This is the mid-surface that actually we created, the FEM level, mesh level, simulation. I need to go to the mesh level first because I need to mesh it. And because basically we have the surface here, we need to use a 2D mesh. So I'm gonna click on the 2D mesh. I'm gonna choose each of these one by one, or you can click on Control and A, hold them together to just choose everything. I'm gonna use the C quad 4 with the 4 nodes, element size 3 mm, and I will click OK. Great, so I've created my mesh. You see it actually automatically put it into the 2D collectors for me. And if I go, I will be able to see my 2D mesh over there with the 1342 elements. If I want to change that, I can double click and change it. So now what I need to do, I need to add a thickness to it, because in reality we have a thickness, and also I need to add a material to it. So what I will do, I will move from the mesh a little bit higher, so upper level, to the group of it, which is thin shell. I can either double click, right click, and go to edit, and I will edit it. So let me put the thickness for 4 mm, for instance, here. I can define my material in here as well. So I'm going to use steel 4340 isotropic, and I will click OK. Make sure actually they would apply to the material for the 2 and 3, because these are different surfaces connected to each other. I will click OK and OK. Great, so I've done with the mesh, I've defined the material as well, I've added the thickness. What I need to do, I need to go to the simulation level to be able to fix the model and also add the load. In order to add a constraint, I will go to the constraint type here. I'm going to use the fix constraint because I'm going to fix those 4 holes. I'm going to choose the edge of each of these holes in here. And these are squares or whatever, so the holes are gonna fix those. So I have 4 objects, I'm gonna click OK. I'm gonna insert the force on those 2 holes as well. Use a normal force, go to the force, I choose that edge, this edge as well, amount 20 newtons. I'm gonna put into the negative Z. Great, so it's a negative Z as well, and I click OK. So I've done this as a step, but because these are created by the surfaces, each of these, they are not attached to each other. And in order to actually make them attached to each other, what I need to do, I need to go to the load and conditioning here, simulation object type, use the edge to surface gluing, because what I wanted to do, I want to glue them in here together. So I click on edge to surface because the edge is going to be glued to the surface. I need to create the edge region first because you see I don't have any edge here. So I go next to it and create a region. I'm gonna click there and there. So those 2 edges, I'll click OK. Surface region, same, I don't have any surface yet. Go there, and because I'm gonna glue it to everything, I choose this one, and that one. Click OK. I would add a 1 mm distance as well for it, and I will click OK. So what you see, it actually is glued. These 2 are glued with the main surface as well. So now we are ready to go. We just need to click on solve and solve the model that actually we created. Click OK. You see that actually the job monitor is still in progress. I'm gonna wait for it to finish the job. Completed. Great, and also Nastran deck successfully written, so I don't have any problem in here. I will close this one down. I would cancel that as well, and you see the actual results appear with the plus sign, and also it's colorful, which means it's active. So I just need to double click on that. So you see it's a structure study, and I can go for instance to displacement, the magnitude. You'll be able to see that actually I have the displacement here. It's really small if you see, but this one is trying to exaggerate it for you to be able to understand it better. You do have a displacement over there. And for instance, if I want to get the stress elemental nodal out of it, I can go there. You will be able to see I have the 0.834 megapascal stress there. If I want to animate it, I can click on play and animate the model as well. What I can do also, I can make the viewpoint. So let's make let's make 4, for instance. I'm gonna create 4. The first one, we're gonna show the magnitude, or even the first one. Let me actually, yeah, we can choose the magnitude, for instance, over there. For the second one, I'm gonna add the von Mises, the stress here. For the third one, let's put the reaction force, the magnitude. I'm gonna put it there. You see, it actually is the reaction forces over there because we fixed them. And the last one, I'm gonna create the graph. Yeah, create the graph in a second. So because basically it would be applied to there. So for the last one, I'm gonna create the graph for the stress. I'm gonna go with the von Mises again. This one, magnitude von Mises. I will go and plot it. I'm gonna drop it into the viewpoint number 4. So make sure this one is a stress. What I would do, I create the graph for it. Create graph. I need to choose a node there. And yeah, we have the highest stress over there. This one, we're gonna compare it with the area that we don't have any stress. And I'll click OK. And I'm gonna apply to this viewpoint. So you see it actually, I do have the stress along the path as well. Yeah, something actually before we go to the tutorial number 2 I want to add is just how we will be able to create the report. So what we need to do, we need to go to home, click on create report, but as I said, because I have a problem with the Java, it doesn't let me to do it. But if in case you've done that, because I've already done that before, so I can show it to you. And here, if I go there, you will be able to see it. Actually, I created the reports in here. And if I go to the folder, see it actually a report folder is created. If I click on the simulation report, you would be able to see the material, the stresses, how much force that actually we put on it. Also, we would be able to get the different graphs that actually we also created as well. So once we finish this one, let's continue with the tutorial number 2. Thank you. Good. So let's practice the tutorial 2 together. If you remember, we've done the mesh on this model into the previous lecture. So that was the model we had, but let's practice it together. So this one is a Finite Element modeling file. I need to create the simulation file. So I go there because this one is already half the FAM. So I don't see any other option. I just see the simulation. I'm fine with that. So this is another way of opening the simulation, by the way. So again, in here, so I need to route it to the folder I want to save the files. Now I need to choose what type of the templates I'm going to use. I'm going to use NX Nastran, so I choose this one. I can rename it as well, and I will click OK. Automatically loaded the file for me, and I can preview it as well in here. I will click OK. So now I need to choose the solution for it. So I can rename my solution. I'm happy with the NX Nastran solver. It's a structural analysis as well, and I'm gonna use the linear statics global constraint, and I will click OK. Great. So I will open the simulation file view. I'll go to the mesh level because we need to mesh this one first. I go to the 3D. I'm going to use the 3D swap mesh because I have the 3D object. The geometry is complex, so I'm going to use the 3D swap then. And if you remember, we've done the swap mesh from the top to the bottom as a target. We use the C hexa and with the 8 nodes. We use the 4mm as a node. We also tick the atom-free map meshing, and then we click on OK. We've done the same things on the other part as well. So go to 3D swap mesh again here, there, C hexa, 4mm free map meshing. In here, we've done from that surface to the other surface. So I had to first untick the mesh and hide the model to be able to access there. Good. And I use the 3D swap mesh from there to there. Again, CX8, 4mm, and okay. If I want to bring it back, I go on to top, show and hide, show everything. Okay, and also the mesh is activated once again. The last part, 3D swap mesh from here to their 4mm C hexa free map meshing and done. So we've done those parts as well. And if you look at here, you see that I have 1, 2, 3, 4 different meshes, 4 solid meshes. And I'm ready to go. Before I go to the simulation part, I need to define the material first. So go to each individual group in here, into the group of it. I'll click, edit, edit again, material, choose material, and here we're gonna use the aluminium 6061. I'll click OK and OK. So the other part, do it again, edit, edit, because I already defined it, so I have it here. I will just put it there. Okay, okay. Again, another part. Great, so we've added the material as well, and now we can go to the simulation level. Great, so in the simulation level, what I need to do, I need to fix the model first, or add a constraint, so I'm gonna fix them in these two. So go to the constraint type, because these are actually fixed with a pin, I'm gonna use the pin constraint there. So I'm gonna choose the surface of those here on the top, so both surfaces on the inside of the cylinder, and we'll click OK. So fix them using the pin constraint. In here, I'm gonna add the pressure as a load over there. So what I would do, I'll go to the load, choose pressure because it's a pressure force, and I'm gonna put the pressure over there, and I need to put the value of how much megapascal I can do. But let's make it a little bit more interesting, and rather than I just type in, I'll go there and I'm gonna add a formula to it. So what I need to do, I need to create a new field, formula. I'm gonna name it as pressure. I need to add a domain first, so I'll go and make one element become independent, and then the rest will change based on that. So I'm gonna use X as the independent value, so we'll add it there, and here it automatically creates for me a pressure, and expression is 0. I will click on expression and I can type the formula for it. So this is the formula I'm gonna use, the sign variations, and so you can type it there, and once you're typing, actually it's help you with that. So for instance, when I put sign, automatically find actually it's a sign for me, then I can type the rest, and it's trying to find the similar formula for it. Do you see that? So I can just continue with that. And once you're happy with your formula, you just accept the edit, you click OK and OK, and you see that actually pressure now has the formula to it. We'll click OK. So I've added the formula to it. So everything is now ready. I just need to solve the solution. I'll click on solve and I will click OK. Let the NX Nastran to go and solve the solution here. I'm gonna check whether, yeah, this one is completed, so we'll cancel this one, we'll close this one, and you see the actual result in here is appeared, and also it's colorful, which means that actually is the result attached to our simulation for the structural analysis. Let's have a look to the displacement. You see that actually I have a displacement in here. I can see the stress, elemental, bone misses, elemental nodal. You see I have 1 megapascal is the maximum of the stress elemental. If I use this one is a 0.596, so this one is the element, that one is the element nodal. So we've already done those. What else we want to do? Again, if you want, you can add them into the 4 different views. Let's have the magnitude in the first one. Second one, I'm gonna add the stress element plot here. Third one, I'm gonna use the stress elemental nodal there. And let's even create the graph as well. Choose the 2 nodes. I'm gonna choose that one. Gonna choose, yeah, this one for instance. I'll click OK, and I'm gonna put it on that view for instance. So this is how we want to put them side by side in order to actually study them. If you want even to animate those, you would be able to animate them as well, see how much pressure actually is impacting. I'm trying to put the express on the model. Again, to get the report, what I will go there, I will just go there and click on the create report. But as I said, unfortunately, I have the problem with the Java, but I've already done that before, so I can show it to you how it will look like. Let me close this one. By the way, once you finish, make sure you save it. I haven't saved the file, so you just use the Control S, or you go to here, File, and save it. So in here, you see actually I have the reports there, and once I finish the report, I can have a look into my folders that actually a simulation report is created for me, which I can see the forces that I put, the different mesh we use, how many elements we have, how many nodes we have, how much pressure we put, and also get the results, the graphical results as well. Great. So hope you learned this one as well, and please contact us if in case you have any other questions. We are more than happy to answer you. Take care, have fun, bye-bye.